Okay, I've got 932, so we'll go ahead and start. You should be looking at our map check on my main screen. And just to look ahead on Thursday, we'll have a Zoom, same time as we're having today. And I'll talk about what we're going to do on Thursday. And then coming up on Sunday, we've got all the Pearson that's been assigned to date. That's all the homeworks. I think we've got one more validation for this week. And there's also an extra credit out there that if you're interested in, that's due as well. So that's all coming up on Sunday. And then as we look to this time next week on Tuesday, we'll have a Zoom for prep session, and I'll take your questions ahead of time. That'll help, as usual, help me prep for that and make it to be what you want it to be. And then 9 days from today, we'll have our second exam. Now, here's what we're going to talk about today. I've got some general comments to make, and then we're going to go into this model concerning inventory called the economic order quantity. Um, and I'll talk some more about what that does. We'll talk about its assumptions and limitations, the components, what we can use out of it. And then at the end of all that, we'll get oriented on what we're going to do between now and Thursday, which is an exercise called the squad drive. Essentially, it's a U drive on your own, but you can work together for help. And I've organized you in the squads, and I'll show you where that is all on Canvas. So I am recording this today so that if in the event folks miss it, they can come back and watch it later. And if you're on right now and you get lost or you want to just review it later, you have the ability to do that. So what I'm going to do now is go to the whiteboard. Okay, so that's what you should be seeing right now. Is everyone seeing the whiteboard now? Everybody give me a thumbs up. Someone give me a thumbs up. All right, super. Okay, so economic order quantity. Oh man, I think I gotta, okay, let's try this. Economic order quantity. First of all, the purpose of inventory is to hedge our bet. With inventory itself, we want to balance two things. We want to balance the demand, okay, that customers have wherever we are in the operations chain or the supply chain, so that when people come in, they can get what they want and need. But is my very rudimentary scale. On the other side of that, we want to balance the investment and the cost, because the bottom line is when we put items on the shelf. So, for example, the example we're going to run with today is a sporting goods store. And so we stock the sporting goods store with bats and balls and things like that because we think that folks are going to come in and buy it. But the issue is that um, if they don't come in and buy it, then in the end, that's lost money that we could have spent on something else, anything else. We could have spent it on another item of inventory. We could have spent it on marketing. We could have spent it on um, some kind of additional service for ourselves. We could have just invested it. We could have bet on a horse. We could have done so many other things with that money. So this is a constant balance with inventory, and EOQ is not the only way to manage inventory. And in a lot of ways, it's very limited. But the importance of EOQ is just kind of getting a foundation on how we achieve balance and how we could manage inventory. So There is a slide on your canvas for today. I'm not going to go into all the assumptions that we have to make when we're working with EOQ. But the bottom line is that, and this is where EOQ has a lot of kind of naysayers, that people believe that EOQ is kind of outdated, is no longer relevant. And quite honestly, the first time I ever saw EOQ, I thought, there's why, when would you ever use this? Um, but it is valuable in just establishing a baseline. Okay. And that's all we're going to do today. That's all we're going to do this week when we work with EOQ. Um, the bottom line on assumptions, and there's more than just two, but that our demand is constant. This means that however we define demand, that demand moves at a steady rate. If it's 50 one day, it's 50 the next day, it's 50 the day after that, and so on and so forth. And already, especially in these times, you can see, when is demand ever truly constant? But again, it's a base model. The other key assumption is that lead time is also constant. Now, lead time is the definition of lead time is, let's just talk about what lead time is. Lead time is the time that passes from when I put an order in to when I get it. So if I go on Amazon today and I order some ink for my printer, and I don't get it for another 3 days, the lead time is 3. That's what lead time is. Now, again, you can see, well, when is lead time ever exactly constant? And there's some instances what I could quote that lead time is constant. Harley Davidson works probably a lot under EOQ because they have a lot of certainty in their life. And there's probably other operations that work that way. So these have to be in place. If we have a situation where we're trying to model inventory and either demand is not constant or lead time is not constant, then we shouldn't be using EOQ as a model. And that's very important to realize. Now, let me just jump into a very rudimentary design of an operation or supply chain so that you have a framework to operate from. And I'm just going to jump into our example that we're going to work with today. So what we're going to work with today is we have a little company, sporting goods company, started by some of the folks, the warriors that you know. Luke, AJ, Tim's got a piece of the action, Kyle's got a piece of the action, Brandon. And this is a baseball sporting goods company called the Swingers. Now, these guys didn't really talk to me before they chose this name, so, I don't know how you feel about that name. But, you think about swinging a bat at a ball anyway. So they get supplied by a supplier that brings them various sporting goods. Today, we're just going to talk about bats. And they move out bats at a certain rate to their customers. So we have a demand here, and we have a lead time here. And under our example, they have constant demand and they have constant lead time from their suppliers. Okay. So this could be a distribution center that they're running. And you think about distribution, just think of the guy who fills up the Coke machine. He comes by at a regular interval, he fills up the Coke machine. moves on to another one, fills up the Coke machine, so on and so forth. And he does that on a regular route. So Luke and AJ could be doing that. They could be having people come pick up, but their demand is constant and their lead time is constant. Now, back to EOQ, economic order quantity. What does that mean? Well, what we're trying to do, I talked about balance before. Now I'm going to talk about some different things we're trying to balance. With all things operations, and we are always trying to minimize cost. Not always, but usually. In some instances, we're trying to do something else, but in this, we're trying to minimize cost. So we have two costs that we're trying to minimize. Okay, in terms of inventory. And I'm just going to write them over here in color. We have holding costs. Holding costs refer to the costs that it keeps that we have to pay to keep an item in inventory. Okay, holding costs refer to security, they refer to accountability. If we're in the food business, they might refer to refrigeration costs. If we're in the weapons business, they might refer to security, things like that. Holding costs, those all wrap under holding costs. And if this axis here is the quantity of the item, Q, then, and this axis here, the y-axis, is cost. So for holding costs, the pattern usually looks like this. The lower quantity we have that we're holding doesn't cost so much to hold. The holding costs aren't that much. So let's say that I have circuit cards or some either lower dollar value item, and I have one of those in inventory that I'm holding. Well, that doesn't cost me much space. It doesn't cost me much labor to maintain that. It really doesn't cost me that much. But let's say all of a sudden I go up to 500 of those items. Now my cost, so I go up to 500 out here, my cost goes up a lot because I've got to count those items. I've got to keep track of those items. I might have to do something to those items, maintain them. The longer I keep them more in inventory, and the more that I keep in inventory, my costs go up. So that's what my holding cost line looks like. Now, the other category of costs that we have with inventory are ordering or setup costs. And I'm just going to put an O/S. Now let's talk about ordering for a second, because that's probably easier to quote get. Ordering is kind of like shipping costs, but the bottom line is ordering costs are the costs that go into ordering something. So let's say I don't have a home gym and I'm just really bored and I want to work out and I'm going kind of crazy. And so I get on to Rogue Fitness. Rogue Fitness has been doing a ton of business, by the way, but that's another story. So I get on a Rogue Fitness and I order one 70-pound kettlebell. Well, part of an ordering cost is a shipping cost, and that's not what this S is. But if I order that 70-pound kettlebell, and let's just say it cost me $70, and I order one of those, then my order cost is going to be very relatively high, because the ordering cost that goes with that kettlebell in terms of shipping is probably going to be about $40 to $50 of shipping cost alone. So I'm going to pay $120 or $125 for one kettlebell, and almost half of that is consumed by ordering and setup costs. So, but if I order more and more kettlebells, eventually that line will go like this because I'll be able to spread out the shipping cost across those kettlebells. You can see this if I order more and more items. So for example, if I order that one kettlebell, but I order 10 more pieces of kit that aren't that heavy, like jump ropes and things like that, then I can spread out that my shipping cost is really not going to go up that much. And so as I order more items, my order cost goes down. And let's talk about setup cost. So let's say that I'm having somebody make something for me, like make a t-shirt, and I just have them make one t-shirt. Well, they've got to configure their machines to make that one t-shirt, especially if it's like a custom design, and they're going to make me pay for that. But if I order, let's say 200 of those shirts, they're probably only going to charge me that setup cost one time. And that allows me to spread that setup cost across those 200 shirts. So that also makes this line go down. So ordering and setup costs, they're not the same thing, but they go in the same category when we look at the balance of these costs. So what is the purpose of all these lines? Well, the purpose of this is what we want to do in operations is we want to find the quantity that refers to that point there. And that quantity is EOQ. So in other words, where the holding cost and the operations slash setup costs are the same, that is the economic order quantity. I'll say it one more time. Where the holding costs and the operations setup costs are the same, that is the economic order quantity. And what that means is every time that we order that item, we want to order that quantity because at that quantity, we're achieving this balance. And therefore, if we were to draw our total cost line, our total cost line looks something like this. It starts here and hits its lowest point right where that EOQ is. And then it goes back up. And that total cost line is that blue line plus that gold line. So that's why every time we order, we want to order that EOQ. And again, EOQ answers how much. Okay. So let's go on to the formula then. EOQ, the main thing here, it answers the question, how much? How much do we order? And in terms of a formula, EOQ equals the square root. Just going to go with some different colors because kind of getting a monocolor thing going on. We actually have a constant here of 2 in the numerator. And then we have what's called, I call this big D. And then we have a constant S. And all divided by H. Actually, S is not a constant. These are variables. I'm sorry. 2 is the only constant. So that's our formula. Now let me talk about what each one of these means. So D refers to annual demand. Pen getting kind of out of whack there, sorry. That's how much demand we incur for that item within a year. Now we're also going to see little d, and you've got to distinguish this in the context of a problem. This is one of the leading challenges that warriors have, is that they see little d and they think it's big D and the other way around. So a little tattoo you might want to have is that little d does not equal big D. They are two different things. They are related, but they are not the same thing. It's kind of like saying your little brother is the same as you. Well, that's not true. Your little brother is your little brother. You're you. You're related, but you're not the same thing. That's so awesome. And I just thought it up on the fly. Anyway, little d is daily demand. Okay. And while we're on this here, we might as well go to a new screen. So let's talk a little bit more about how we get from D to little d, how we do that conversion. Well, it's actually very simple. So if we want little d, we need to know the number of work days that we work in a year. Actually, I'm going to put that there, and then that there. Okay. So this is the demand we incur in a year. This is the amount of work days we work in a year. And so, think about just common sense. If you're working a 5-day work week, that actually is, I think, 260 days in a year, assuming you take every weekend and you take no holidays. So you're probably working less than 260 days in a year, if I did that math correctly. But regardless, if we want to know D and we know these two, we can find D. And then if we want to, or little d, if we want to know big D, the worst looking D in the world, we can do a little bit of algebra here. D times WD, not WD-40. So while we're here, just don't be tripped up if you have this D, but you need bigger D for the formula. And that goes over the whole thing. If you need big D, but you have little d, well, find out what the work days are for the year. And then you'll be able to figure that out. Or if you need little d, and you will need little d for something else we're going to do later, then you know how to figure that out. Okay, let's move on to the rest of these things. So S stands for setup/ordering costs. That means every time we place an order, what is that setup or ordering cost that we're being charged? And then H is holding costs. How much do we have to pay per item per year to hold it? So let's jump back into our example now that we have this formula, and we'll work a number of other things as we go. Okay. If I go too fast too, please jump in the chat and just say, "Hey, can you slow down a little bit?" Um, that's perfectly cool. I would like that you do that rather than just, "Hey, I'm too fast," and kind of no fun kind of thing. Okay, so we're gonna go back and talk about the swingers some more. And so the swingers, they've decided that they're gonna work 200 days a year. And we're talking about bats today, and they have a daily demand for bats of 25. Get rid of this fat finger here. That's much better. And they're set up in ordering costs every time they order a bat. Okay. They have to pay $6 per bat. Now, we could do this in terms of cases of bats, but we'd need to be talking apples to apples. So if we're talking about cases of bats, then this would be cases and this would be cases, or this would be dollars, excuse me. but this would be cases right here. We'll just say it's per bat. So their demand is 25 bats per day that they're sending out to their customers. And every time they place an order for a bat, it's $6 from their supplier. And they have somebody doing warehousing for them that charges $3 per bat per year. Now we know that 25 times 200 is 5,000. So our first question could be, every time that Luke and AJ order bats, how many should they order? And so to balance out costs, we're going to go here. We're going to go to 2, put that 2 in there. We want to put D in there, so we could either put 25 times 200. I'm just going to put that 5,000. And we put that setup cost up there in the numerator. Now, here's the thing that Warriors, I've found, want to do something special with this 3. You don't need to do anything special with this 3. I know the definition is a little kind of cumbersome, $3 per bat per year. And so you want to times it by demand and all this. Don't do that. Just take that and put that right there. That's all you got to do, okay, to get what the EOQ is. And in this case, the EOQ is, I get 141.42. And with this, with the EOQ, I'm not normally like this, but I would really like you to focus on the unit of what we're talking about, because things are going to change. The dollar signs cancel out. So that dollar sign here and that dollar sign cancel out. So this is indeed a number of bats. Okay. So that means every time Luke places an order to his supplier, he's going to order 141.42 bats. Okay. That's what that question answers. Now, we'll go into a couple sets of things we can look at. One of them, let's look at costs and how much this is going to cost the swingers per year. Oh, and I'm sorry, before I forget as well, you could do all this in Excel, and I would definitely encourage you to do that. I'm not doing it in Excel right now because I feel that when I do, at least on this platform, I can't write the formulas and I have to bounce back and forth, and I just feel like I would lose you potentially if I don't show you that formula. I want you to see what that looks like. So I can provide an Excel model for you later and put it on Canvas. And I would encourage you to do this, all of this in Excel. And the reason for that is when things change. So if that 6 changes, if AJ's supplier changes that 6 to a 12, we know this whole thing is going to go up. If the warehouser drops the holding cost down to like 0.5, we know this whole thing is going to go down. But the problem is that holding cost alone is not going to drive that down very quickly because you have so much here in the numerator. But the point is, you don't have to be super smart to figure that out. If you put it in Excel, you can make those adjustments and play the what if game like we have doing other things. So let's go on to costs. So we have annual costs that we can compute for both holding and for ordering. Okay. So it's formula time. For holding costs, the formula is the amount EOQ. I'm going to write Q because sometimes EOQ is not Q, but I'm just going to write with an asterisk. So you need to know that's EOQ. And we're going to divide that by 2. and we're going to multiply that times the variable of H. So in our example today, we have 141.2 bats divided by 2. And then we have a holding cost of 3. So that's going to equal 212.13. Now for ordering / setup costs for the year, that formula is going to be big D divided by Q times S. So if we remember, big D was 5,000. Q is this Q. So these Qs are the same, and that's that EOQ, 141.2. And we're going to times that by S, which was 6. Now, this is very important, what's about to happen. And this is corny. I had this idea that I would kind of ask you as if I was asking you. But I want you to think about right now, all of you, what should this number look like that we're about to get? Well, remember the purpose of EOQ. We're trying to balance annual holding costs or holding costs overall with ordering and setup costs. So this number here should be the same down here. And when we do those computations, it works out so that it is indeed the same. So in the spirit of Ice Cube, when you're doing these problems and you're figuring these kind of costs here, if these do not equal each other, you have done something incorrectly. That is a check that you want to watch for. Now, the last component we have in annual costs for bats in terms of inventory, okay, is simply the product cost. Okay, and the product cost is equal to the amount that we need times the price that our supplier is charging us. Now, do not confuse price with setup ordering costs or anything else. Price is price. So in this example, I didn't tell you it on the other screen, but we have demand. This I told you, 5,000. That's that 5,000 here, that D, same thing. I didn't tell you on the screen that they actually charge the swingers 50 cents per bat. So this would be 2,500. And so the total annual cost in terms of inventory is these two plus that, which is 2,924.26. Now, a couple things here real quick. This, of course, is not going to equal these. That's completely a horse of a different color, like that, Kylie. Anyway, it's horse of a different color. You just got to remember what price is. So you want to focus on that and make sure that's clicking with you. If it's not, what price is, that's the price that we're paying from our supplier. In this case, AJ and Luke are paying whoever's supplying them these bats per bat. And this number here, there's no hard and fast rule here, but this number here will usually be much larger than these numbers. That's just the way it is. Usually because D is so much bigger there. So that's a way to configure this. So what we're looking at is annual holding cost. That's our formula. Annual ordering / setup costs. This is our formula. And our product cost. This is our formula. And then the total is indeed the total. And so if in the nature of a problem, I ask you, well, what's the annual setup cost, but you haven't determined EOQ yet, well, then you have to go back and do that first. okay? Because you see how we need EOQ to determine these other costs here. And if we don't have that, then we can't do that. So that's the first kind of bucket of things that we can get out of the EOQ model. The second bucket is some other questions. So EOQ helps us answer how much? But we might also want to know how many times. How many times do we order throughout the year? And a little bit to my chagrin, we actually call this variable N. And I don't like that because we use N for a number of things in both statistics and operations management. And I don't really care for that. But in the context of this problem, N is defined by D divided by that EOQ. And if you remember from the previous screen, this is a component of annual setup costs, but this alone determines N, and N stands for how many times are we going to order throughout the year. So it is a matter of times. It's not units, it's not dollars, it's times. So let's just do this example. If the swingers have a demand of 5,000 bats throughout the year, and they've determined that every time they order, they need to order 141.2. And I know you're thinking, well, do I round that? We'll just keep it like that is for now. That means that they're going to order, lost my place here a little bit, 35.36 times throughout the year. Okay. At regular intervals, not sporadically. They're gonna order at regular intervals. Okay. So again, this is not an amount of bats. This is not a dollar figure. This is how many times. And I would really prefer you to write it that way. And that just shows that you know what you're talking about. And so N answers that question, how many times they're going to order. Now, they might also want to know how much time passes from one order to the next. And so to determine that, I actually need N to determine how many times. I'm just going to change my color because kind of going monocolor here. So to determine T, I would need that number of work days, and I'm going to divide that by N. So in our example, the swingers work 200 days per year, and they order 35.36 times throughout the year. That means that about 5.65 days pass between one order to the next. Okay, so if Luke places an order today, 5.65 days from now, he's going to place an order again. And that's work days. So if he works and then he doesn't work on the weekend and he goes and plays some ball, those days aren't counted. You don't need to overcomplicate this. I actually tried to earlier today when I was prepping, and then it's just work days is work days. So 5.65 work days pass between one of Luke's orders to the next time he orders. That doesn't mean that 5.65 days pass between the time that he orders and the time that he receives it. That is lead time. Okay. So T refers to the time that he orders the item to the next time he orders the item. And we have a thing that we'll reinforce a drawing here at the end on that. So those are kind of our two big buckets that we're going to have on EOQ. The first is costs, and then the second is these other questions. And so again, T says how much time passes between one order to the next. Okay, so two different questions that complement this question. And then the next thing we're going to talk about kind of complements EOQ, but it's not EOQ. And that is a thing called ROP. ROP stands for reorder point. Okay, now I'm gonna put the swingers to the side for a second. No offense, guys, and I'm gonna talk about another example of reorder point. What is a reorder point? A reorder point is an inventory level that triggers me. And when I say trigger, that doesn't mean like makes me mad. It triggers me to put in my order of Q. So let's suppose that I have shelves, and each shelf holds 100 boxes of Lucky Charms, and I only have 4 shelves. So I'm going to start whatever. We'll just start my month period with all shelves full. Reorder point is something like this. So when I empty out the first shelf, I don't do anything just yet. When I empty out the second shelf, when the last box goes off the second shelf, I reorder. And in this case, I would reorder 400. Now you may think, well, you only need 200. Right. But by the time my 200 arrives, I'm going to be empty. So I'm going to order 400. And I'm going to show you that another way. But the point of this diagram is reorder point is the inventory level. In this case, it would be 200. Okay. It is the inventory that once I hit, I put my new order in. Okay. Under this model, maybe we'll just pretend that my EOQ is 400. Notice how these are not the same thing. So the bottom line is that this tells me when I reorder. EOQ tells me how much. Okay. So it's an inventory level. When I hit 200, I'm going to reorder. And just for the assumption of this model, and I'm going to reorder 400 when I hit that level of 200. If I'm at 300, I'm not going to reorder yet. If I'm at 250, I'm not going to reorder yet. If I'm at 220, I'm not going to reorder yet. If I'm at 200, I'm going to reorder, and I'm going to reorder 400 every time. I'm not going to order 300 one time, 330 another time, 400 every time. So let's look at the relationship real quick before we talk about formulas. And I think this is tattoo time right here. I really do. So if you can capture this while I'm writing it down or go back and capture it, I think that'd be worth your while. So here we have EOQ land, and here we have ROP land. And in terms of variables that change, let's get some different colors going. Over here we have setup cost, we have holding cost. If those change, they're not going to affect our ROP. Over here we have lead time. If lead time changes, it's not going to affect our EOQ. If demand or its big brother, D, change, then in terms of one, then the other one will be affected, and vice versa. And also what goes in here is the amount of work days. If work days change, because if work days change, then these will change. And if these change, then both of these changes. So I'll ask you, as we continue on with repping out in this material, I'll ask you, if ROP changes, does EOQ change? And what you need to know is what changed about ROP. Was it lead time? If lead time changed, then EOQ will not change. But if one of these changed about ROP, then yeah, EOQ will change. And vice versa. Hey, EOQ changed. So Ethan, does ROP change? Well, Ethan has to find out what changed about EOQ. Excuse me. Did setup cost change? Did holding cost change? If so, ROP is not going to change. But if demand, either way, you slice it, changed, or if work days changed, then ROP will change. So the formula for ROP is quite simple. It is demand times lead time. Very simple. Little d, make sure you've got that. And just to take a tiny tangent, this really shows, again, under EOQ, this formula is valid. If we're not under EOQ conditions, we would alter this formula by adding something that has to do with probability. And this right here is obviously a lot more relevant with most items in today's situation. But because we're under the constant of the EOQ model of constant demand and constant lead time, we don't need to add that on here. Okay. So all it is demand and lead time. Okay. So let's look at our example. I think I have room. In our example, we have, what do we have? With the swingers, terrible color for the screen. We have another terrible color. We have demand at 25 bats per day and lead time. That means from the time that AJ puts an order in for bats to the time that he gets the order, in our example, is 5. And so we know that the ROP is 25 times 5, which equals to 125. Okay. Now you may be thinking, okay, so what? I still am not really tying all these concepts together. Well, let's look at a way we can do that, and actually a quite classic way in operations management that we do that, and it's called the sawtooth diagram. So this is time. Gosh. And in our model, we're going to be going by days. I think most of the time you're probably going to go by days. Okay. And then this axis is inventory level. So we're doing that for the amount of bats that we have on hand. Okay, so now we're going to tie all this stuff together. I'm going to show you how it ties together. So we're going to start our inventory level at EOQ. And we know for that, our example here today, that was 141. Okay. And this is our etc. Now, the way that we should look, think of our shelf of Lucky Charms. $125 is our ROP. And I actually really, this is really not to scale, but we'll just roll with it. So that's our level. When we hit ROP, we need to reorder 141. So let's see when and where we hit that. Well, remember, D is 25. So we're not going to hit that. We're going to hit that. I think roughly, we're definitely going to hit it in the first day, because if we take 141 minus 25, we're going to go below 125. So that's where I was kind of not real happy with my diagram here. And once we hit it, we're going to order 125. In our example, our lead time was 4. So we're not going to get that 125 for 4 more days. And so 4 days from there is we hit this axis about here. 1, 2, because we ordered a little bit before the first day is up. I really don't, these lines should be straight. But the point is that we continue to operate until that shipment comes in. And under EOQ, when that shipment comes in, we go back to 141. So I'm drawing this line in a different color. So that's one of the assumptions of the EOQ model, meaning as soon as it arrives, it goes right into stock. And you can think about, in reality, this might not happen that way. It might have some delay time before it's available to customers and those kind of things. But under EOQ, it goes right back into stock. And then we pick right back up with our depletion line again. And it's going to follow the same pattern as before. And we're going to hit the axis somewhere out in here. Here's the main thing that I would like you to take away from. Number one, we start off with EOQ up this top line. Number two, when we hit ROP is when we reorder that EOQ. So church and state, we started EOQ. When we hit ROP, we reorder EOQ. Now, the difference between this right here and this right here is T. From our earlier conversation. So the distance between that point and there is our T, the interval between orders. The distance between here And here, so this time, if we were to drop this down right here, that time right there is lead time. Again, don't confuse the two. Luke orders it, he gets it 4 days later. At the same time, there's 5.6 days between one order to the next. Okay, so that's how all these tie in together. Um, Again, the purpose of this diagram is I really want you to just relate all these concepts together. Um, it's probably less likely on an exam situation that I'm going to have you portray this, but I do want you to know what you're talking about, church and state and all that kind of stuff. Okay. So that concludes that discussion right there. I want to quickly orient you the um, to the squad drive assignment for Thursday, and then take any questions that you might have. So let me do this. Okay. So let's get into Canvas. And you can't see that right now. So we're back up here. So if you look at on your Canvas today, either right now or when you get a chance, you'll see that beyond the day, we have a page squad drive and squad assignments. And so you'll want to pull this up and let me just talk about it real quick. So the bottom line is I've organized you into squads. That's the first thing is you want to check out what squad you're in. I've posted a squad drive for you here. Just pull it up a second. Okay, so it looks like this. And throughout the squad drive, you have these areas of focus. So the bottom line is I want you individually to do the whole thing. Knowledge is knowledge. But in prep for Thursday, I don't ever like putting anybody on the spot. Um, so what I've done is I've given you squad areas of focus. So the point of Thursday is that I'm going to ask someone for these to describe these answers from like questions 1 through 3 from squad 1 on Thursday. And I'll have a specific person in mind. I won't tell you who that is ahead of time, but I'm narrowing it down so you can kind of hedge your bets and say, hey, if I'm Kyle, for example, Kyle Beckwith, he's in squad 1. Okay. I really got to know these answers just in case I get called on and I can drop some science with defiance, mad skills kind of thing. Now, so you want to do this by yourself, but you're also required to do 2 more things. And so you've got a discussion board over here, which we haven't worked in before. And I've built some squad space for you. So if I'm Kyle, I go here to squad 1 discussion, and I'm required to do 2 things. I've got to offer help or ask for help. That's it. And I can do that just cold, go in here and say, hey, I'm totally lost on question 1. Or I can say, hey, I think question 1 has to do with X, Y, and Z, and here's kind of what I came up with. And so you're required to do that here in the group space. So I can monitor that and see that it's going on. I don't want anybody to take away the wrong impression. I want you to do the whole thing. And not that I wake up in the morning to mess with you, but if I go to squad 1 and they're just not feeling it on Thursday, I'll probably go to someone else to try to see how we're doing here on these answers. But everything here in the squad drive is all the aspects of what we've talked about today, in terms of EOQ, what it's meant to do, and the aspects of ROP. So that's for Thursday. And on Thursday, we'll go over this. Like I said, we'll just start off. I'll say, okay, squad one, and I'll pick a person from squad one and start asking them to talk about this. And I might go to another person from squad one, and then we'll move on to squad two, et cetera, et cetera. It's all about learning. So if you're doing this and you're in squad two and you're looking at your questions and you're like, hey, I know how to do this, but I'm kind of lost on part one, then hey, well, you can jump in here. You're not excluded from the squad one discussion board. You can see what they're talking about. You can participate if you want to. You're not required to do that. So with that, that is the end of that. And I would like to just get any questions you might have on today or anything else that's on your mind, period. The exam, life in general, anything like that. I'd just like to open the floor, whether you want to chat them, type them in, or unmute your mic. Either way. Not everybody at once, though. Is the exam on Canvas? The exam is not on Canvas yet. It will be. Is that what you're asking, Myra? Are we going to do it that way? You mean? I guess in answer to your question right now, it's not. Yeah. Okay. So Myra asks, I just didn't know what way we're going to do it. I don't entirely know right now either. I think what I'm going to do is I will tell you what time it will be posted and available for you to work on. I'll give you submission instructions. We're going to do it all through Canvas. And I'll also give you instructions on how to work and what you can use. Just to give you the obvious, I obviously am not going to be able to teleport to your room and prevent you from using certain things. But I can kind of make it harder for you to use certain things based on time, if that makes sense. Does that answer your question? Okay, super. What other questions, concerns, anything that we have out there from anyone about anything?
So the squad drive, is it due Thursday by class time, or are we doing it during class?
So the question is, when is the squad drive due? So I would like you to work on it before Thursday. You're never going to turn it in, quote, for a grade. So what I'm looking for is to see everyone's, I want to say, participation. What's more important to me is to see that folks worked on it and pursued the answers. So, but we're not going to start out on Thursday cold and work on it then. So you've got a little bit of work to do before Thursday. Does that answer your question, Kyle?
Yeah.
Okay. All right. Other questions? Nice outfit. All right. Yeah, I couldn't find a chicken suit. I just, I have one here. I have a chicken, but I couldn't find it. I couldn't find a chicken suit. So, other questions from anyone on anything? One thing that may not be on your mind right now, and it's certainly okay that it's not, is What about this big project, the Way of the Warrior, that we have due? Gary, I see your question, so I'll go to that. The test is a week from Thursday. So I believe that's the um, 1st or 2nd of April, whatever a week from Thursday is. And like Myra asked, um, yeah, super. I don't know time. It'll be more than 75 minutes, but I'll figure all that out soon enough. And when I do, I'll let you guys know. Way of the Warrior project. I'm not going to stick to the format necessarily that I had prescribed in the past, because of I think responsibilities and challenges that we have with um, social distancing in our setup right now. So here pretty soon, I'm going to give you alternatives to that format. If you'd started with that format and you're well down the road, I don't want to um, compromise your effort, but I want to give you more options if you haven't, or if you're encountering constraints. And so I'll get that out pretty soon as well, as soon as I can. But I am thinking about it. I just wanted you to know that it's on my mind and I owe you an answer. Um, what else? Anything else? I don't need to keep you here all day. Um, I want to thank you all for your flexibility throughout all this, not just with our class, but in general. I know this is a very enormous challenge, and I think you all have done really terrific in adjusting to this format. I know you didn't sign up for online classes, and this probably isn't as fun. It's certainly not as quote fun for me. I miss seeing you guys and all that. But I want to thank you for your flexibility and encourage you, if you have any questions about anything, email me. If we can't figure it out on email, we can set up some Zoom and go after it and figure that out. Um, I will post this video here later this morning, so it's available for you. And with that, I will see you all on Thursday. Have a great day.
See ya.
Yeah.